Hello everyone, we are going to study electrical and electronics instrumentation from electrical engineering. This is one of the subjects, and you can see the unit. Hello everyone, we are going to study electrical and electronics instrumentation from electrical engineering. This is one of the subjects, and you can see the unit. Hello everyone, we are going to study one of the subjects, and you can see. Okay, uh, there are 5 units, and these are the reference books. The first unit is measuring techniques of low resistance, high resistance, and medium resistance. Then we have the bridges or transducers, and what are these? The different machines and devices. Then this is a very specific one. So there are 4 recommendations: Golding and Wittes by the Wheeler books, Herrick and Cooper, AK Sony and HS Kalsi, these are Indian and these are international. So, considering the audience, we will go through this book and some notes. So, let's start the first unit. The measuring classification of resistance and measurement challenges, and the measuring techniques of different types of resistances, like the medium, low, and high resistance. So for this, we have this notes from this college. Now this college application, but yeah, these notes were very, good. What is the first unit of this? Mm, the first unit is PMMC and all. Okay, moving on. This is our book, AK Sawhney. Uh, let's go through it. The methods are given here. We have to look for the challenges and stuff and the resistance measurement. Mm, it should be here only. Okay. This is from 434 for 454. The medium resistance is given as ammeter voltmeter method. 1, substitution second, Wheatstone third, and Galvano fourth, 4. And in here, in the syllabus, we have voltmeter 1, 2, 3, and ohmmeters 4. So we have all of these present here. Okay. We submitted. And low resistance we have ammeter voltmeter Kevin double, and here we have voltage drop potential Kevin double. High we have loss of charge, direct deflection, and here we have direct deflection, loss of charge Mago. Okay, all of these are here unsolved problems. So let's start with this only. Uh, 424 now. So this 408. So we are off by 26, 18 pages. So 424 plus 10, 434 plus 10, 440. Okay, here we are on 440. See, I was correct. Let's make it twice a page. No, let's keep it singular page. Okay, measurement of resistance. These are the classifications. Easy one. Classification of resistance. There can be three types. The classification of resistance from the point of view of the value of ohm. Okay, these three are classified on the basis of the values of ohm, like the low resistance are of the order of 1 ohm, like 3, 4, all these goes into low resistance, and medium resistance are from 1 of ohm upwards to about how 10, 100,000. Okay, high resistance is bigger than this. So yeah, there are four methods: ammeter, voltmeter, substitution, Wheatstone, ohm meter. Uh, Ammeter voltmeter, substitution, Wheatstone, and ohm meters. Okay, yeah, okay, this is pretty cool. We have got everything from what we needed. So let's start with the measurement of medium resistance. Okay, let's study. So let's put the topic medium resistance. And let's understand what was the 454, no, 424 to 450. So we will understand 30 pages in our brain. Imprint it. Okay. The different methods are these four. The first one is ammeter voltmeter. The first one. Okay. This method is very popular since the instruments required for this test are usually available in the lab. The two types of connections employed for we will call this AV method from now onwards. Okay, it's pretty long to say. So there are two type of connection for the AV method, and these are given in this figure. In both the cases, if readings of A and V are taken, okay, then the measure value of resistance is given by V by the Ohm's law. Yes, we can say so. The AV connections can be shunt and series, or you can say parallel and series. And in both the cases, it's V by I. This one is series, and this one is parallel. Oh no, wait a minute. Okay, okay. The um, the V and A, the R is connected with in series with A, the load, and here the R is connected relative. But okay, 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 okay. Got it. The measured value of Rm, that is this Rm. Why it's saying RM, like what does M stands for? It should not be R measured. Okay. So RM guys, it's R measured. See, you have to find the notations also by your brain. The measured value of RM would be equal to the true value R if the ammeter resistance is zero and the voltmeter. Okay, it's talking about the ideal case that RM and the true value it is donating by R. Okay, capital R. So the ideal value is R and the real value is RM, that is R measured. So RM is equals to R if I is equals to 0 and the voltmeter, sorry, RI, the resistance in ammeter, so RA is 0 and RV is infinite. We already know this. So that the conditions in the circuit are not disturbed. However, in practice, it is not possible. Yeah, no. So if this is 0, okay. Circuit of the figure. सर्किट ऑफ द फिगर ओके इसका बट ये तो फिगर ही नहीं था अच्छा फिगर ये रहा इसका सर्किट क्या है भाई एक्सप्लेन करेगा कि इसमें क्या है एमीटर मेजर्स द ट्रू वैल्यू ऑफ द करंट इन दिस सर्किट द एमीटर मेजर्स द ट्रू वैल्यू ऑफ करंट थ्रू द रेजिस्टेंस ठीक है यहाँ पे वी आएगा यहाँ पे वी आर आएगा बट द वोल्ट मीटर डज नॉट मेजर द ट्रू वोल्टेज अक्रॉस द रेजिस्टेंस क्या हो गया बोला in the circuit, the ammeter measures the true value of the circuit of the current through. So ammeter measures the true value of the R and voltage cannot measure the true value of voltage because of this. The voltmeter indicates the sum of voltage across the ammeter. Yes, that was I was talking about. This difference is not equals to this difference because of this. This difference is equals to this difference. Okay, and we will measure this. This is easy. So now RA, in the first figure will be what? R voltage across the ammeter is V not IR. Voltage across voltage. So why it's not saying VA? Now measured value. अच्छा. Okay. It's V ammeter. So VA is equals to RA because the resistance is of RA. Now the measured value is RM A यहाँ पे 1 लिखा है it's 1 here we will call it RMA for this figure so RM is equal to V by I and the V is the sum of it's mentioned in this line it is the sum of the two voltages differences so V by resistance and ammeter so VR plus VA yeah I can understand this now I RA plus I RV what अच्छा IR the ideal what it should be divided by I. So we'll take the I common. So RA plus R. This is pretty easy. Why it's even proving this. True value of resistance is R measured minus RA. So what do we measure? What we have measured, we'll subtract R ammeter from it. And we'll get the value of this R. So uh, 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 we got RM is this. And we put the R plus RA, R plus RA minus RA is cancel out. R plus RA is equals to R is equals to RM minus RA, RM minus RA. And RA is, what is it even? Okay, it's just taking it common 1 minus RA upon RM. And now it's talking about errors. Does the measured value of the resistance is higher than, yes, it is higher. Okay, it is also clear from the above that the true value is equal to the measured only if the resistance, yes, it is. So the relative error is the measured minus what it should be. Let's say it's giving zero point 0.1 ohm and it should be 1 ohm. So that is the relative one. So RA upon R. So the ammeter's resistance upon the resistor, or you can say load resistance. It is error. It is clear that the error would be small. It will be small if the internal emitter resistance is very small. Yes. Circuit of, okay, this is the second circuit. Current from the voltmeter. I is equals to V by RV. Okay. Measured value of resistance equals to R measured is equals to V by I. And I was the addition of I was the addition of the resistor and the voltage. Yes, yes, it will be the ammeter. The current will go here and here. So this is this plus this. And I is equals to V by R. So V upon R, V upon RV, and you can take V common and R as denominator. So 1 upon R plus 1 upon RV, taking common, it will be RV plus R, and RV will go there, RV cancel out. Why it's like this here? Let's see. V by R, V plus V by RV. I think this part is not clear to me. यहाँ तक तो आ गया. Hmm, why does it change into this? V is equals to IR. यार, यहाँ पे if we could have written here as IR, I would have no, no. Only IV would have cancelled out. Okay. Got it. See, this becomes V, 1 upon R plus 1 upon RV, and it is multiplied by R numerator and denominator, so it becomes R by R1, and this becomes R by RV and R. Okay, got it. True value is true value is the current IR, considering the current IR. So true value is V by I, and this is okay. It's talking about R only. So R2, R, how, from here? So R measured is equals to what we got, 1 upon the what we got upon the voltmeter. So if you multiply as whole here, it will be RM. How did it? RV plus R. upon RV. So RM2 into RV plus, it should be plus now. Why it's not taking plus? RM2 in plus RR2 upon RV. Ish, what happened here? What happened? R equals to multiplication of this. How, how did it got here? I just could have done. Okay, these both are R's, no? Sorry. I was not considering the denominator R. So R2 is equals to R1 upon RRV. Multiplying with R2, and we will got R2 plus R2R by RV is equals to R. This will go there. So R2 is equals to R minus R2R by RV. Taking R common, 1 minus R2 by RV is equals to R2. And this will divide. So R2 divided by, so divided by is RV. RV 1 minus R2. No, RV minus R2. I got till here. I got till here. ठीक है, R2 RV upon RV minus R2. Yes, I got it. Now take the R2 common. RV upon, okay, and this RV, this will be common out, and this RV will go into denominator. So it will be 1 minus R2 by RV. Yeah, we are here. We got this value. From equation this, it is clear that the true value of resistance is equals to, if this equals to, the true value is equals to the measured value, if this becomes 1, and for this 1 upon 1, so this becomes 1 minus 0, so it should be 0. For this should be 0, or you can say this should be infinity, because if this becomes minimum 0, this becomes undefined infinity. So this should be 0, this should be measured can't be 0, so this should be infinite. However, if the resistance of voltmeter is very large or as compared to the measurement, RV is very close, so we will consider this as small upon very big 0. So we will say 1 upon 1 minus 0, and it will become 1 only. Okay, let's see. It is very small, yes, indeed. What? It is very small, so 1 plus, it is plus. Thus, the measured value of distance is smaller than the true value. It should be smaller than the true value. Error is the same. And, just- okay. There's the measured value of the resistance. R measured square by RBR. And if R2 becomes R, so this is R square cancels out R upon RB minus. What does say minus? Okay. Mhm. How does we get here? 1 upon very small. So 1 minus 1 upon 1 minus 0. 1 upon 1 should be just R2. Why it's getting 1 plus R2 by RB? Should it's okay from here or what? R2 plus R2 square by RB. Okay. And hence we got this error. R2, the measured value minus what it like should be, or what it should be. So this becomes R2 square of RBR because of this value getting from here. So error in measurement would be small if the value of resistance on the measured is very small. That the error in the measurement would be small if the value of resistance under the measurement is very small as compared to the resistance of voltmeter. Hence, should be used when measuring low resistance values. Okay, okay. It's talking about the method. It's a simple method, but essentially a comparatively rough method, with accuracy being limited to by those of millimeters used, even if the corrections are made for the voltage drop across the ammeter for connector and for shunt effect for the connections. If two instruments are 0.5 accuracy and are read near full scale, they should from 0 to 1%. Okay. Okay, we will do the questions from the next class. That's it for this class. Thank you for joining me. If there is anyone, will definitely study. Okay, that's it.